Adaboosting boosts weak learners by focusing on past errors. Welcome back to my channel. Hope you all are doing good. Today we are going to understand on the Adaboosting concepts and all its techniques, and let's explore that. So let's discuss about Adaboosting. Again, it's a sequential kind of ensemble technique. We understood about two types of ensemble techniques. One is a parallel type and one is a sequential type. And this is a sequential type training process and ensemble technique. And we already understood what are the significance of ensemble technique. And here the same thing is applicable. Adaboosting, in short, that's a short form, but the long form is adaptive boosting. And that helps to combine that learning of weak learners. Like there are so many weak learners, it will take the stages from weak learners and it will understand the errors in each stage. And based on that, it is going to add and reduce weights. And after that, it's going to finalize the weighted voting it is going to take, or whatever the final weights it is going to get, that voting it is going to take, and it is going to finalize the strong learner out of it. So that's the overall point of view of adaptive boosting. And here if you see the same thing I have shown in an example, so you can see that this is one of the data set. So in this data set, I am adding some weight. So you can see that after one iteration, each stage, we are calling that as iteration here. So after one iteration, I can see that okay, let me just get my pen. So this one, which you are seeing here, this one is, having some, wrongly predicted output. And due to that, some weights have been added. And that's why it is called as a weighted data set. Then after that, this is a weak learner, right? After that weak learner, once the study is over, then after that, we are getting this weight data set. Then again, we will go ahead and understand about this weak learner too by adding some, in this stage, we have already added some weight. And here we are just understanding the weak learner too by implementing or by taking that same additional weight of the data point. Then this is the final strong learner we are getting. So in short, we are adding the Adaboosting or the adaptive boosting is based on the weight addition and weight reduction principle. Now we will understand how our Adaboosting works. So the first point, the way I have mentioned already, we are going to see the weights, right? For the weights point of view, we have to understand. So first we are going to initialize weights, and I'm going to show you guys just one more point. I'm going to show you all these steps through a mathematical conversion. After our theoretical part, we will cover that. So stick till end of the video so that you will not miss that particular important part which I'm going to explain. So here, the first point that we are going to take equal weights for whatever the training data points which you have. Suppose you have 100 data points. For each data points, it is going to add some weights. Then after that, we are going to train a weak learner. A weak learner here we are calling that as a single decision tree. That means a single decision tree with a single split. That we are going to talk about as a weak learner. So here that weak learner, even that weak learner is having some correct weight. So we have to consider that and we have to train that weak learner. So once the weak learner is getting trained, there will be some, additional or some error, right? Some error will be there. And that error is going to be calculated by some of the weights of the misclassified samples. What is misclassified samples? Suppose those training data sets are going to predict something, right? And during the prediction, if the prediction was wrong, then that's going to be considered as a misclassified data set or misclassified sample. So we are going to take that and we are going to add some weights to that particular, whatever the misclassified samples we got, we are going to take that. And with that, we are understanding one more important point, which is nothing but our classifier's importance. That means we are understanding here the how important that particular classifier is with this method. And of course, the low error means the high importance of the particular classifier. Then we are going to update the sample weights. Now we got our error. We understood we have some errors. Now we will take those data points or the misclassified data points, and we are going to increase the weights, and we are going to update the weights. So once that weights are increased, and after that again we are going to repeat steps. What are the steps? We have to again train the weak learner to, like we have got weak learner 1, then we are going to take the updated weights and we are again going to train the weak learner 2. Then after that we are going to update, like we are going to get the error, then we are going to update the error. Like that we are going to follow the process, and once the like how our final judgment on the strong classifier is getting into picture is going to be the weight sum of the total number of weights, or like whatever the weak learners we have, it's going to take all the weights and it is going to add the weight sum, and it is going to tell you the, like it is going to identify by sign method. There is a sign method, and that sign method it is going to take, and it is going to tell you which classification it belongs. So that's what, and at the same time we can understand the importance score. And we have core mathematics even in this Adaboosting, how like whatever we have seen or we understood till now on theoretical point of view, we will see how we are implementing with a mathematical point of view. So the first point is like we are increasing or we are initializing the weight, right? So this is the formula. Suppose you have 100 samples, then each weight is going to be 1 divided by 100. That means it's going to be 0.01. Then iterative training, like this is the stage 1, then we have stage 2. In my stage 2, each weak learner is going to trained on the weight data, like whatever the weights we have taken, it's going to be trained on that, and it's going to find the best split to minimize the weight error, right? Then after that we are going to calculate the errors, right? So once we are adding weights, after that we are training with that particular weights, then now we are calculating the error. So this is the formula for calculating error. So once we are calculating the error, that error is nothing but sum of weights of misclassified points. So whatever weight misclassified points which are getting, that means the points which have which have given you the wrong predictions, they are going to take those errors and they are going to add it up. Then finally we are going to get the alpha part, or that alpha part is nothing but the learner weight. That means weak learner weight, right? And that is based on this formula. So this formula is the one which you need to remember. So the alpha value is half logarithmic of 1 minus e divided by e. Here e is your error. What is the error? The weight sum of the misclassified data points. So definitely if the higher if the error is higher, then definitely that data or that feature is going to be the lowest importance. However, if the error is low, that means the feature is having the high importance and more influenced in a particular data set. Then we will update the weights, right? That's the next point. And once we're updating the weights, we need to we need to take all the misclassified samples. We need to multiply by the error part. Then all the weights are getting normalized. So like again, we need to take that into that measurement scale, like whatever we have got the weights. Then the final prediction, it's nothing but we are going to take all the weight sum of all weak learners. That's the point. And we have to predict like what is the sign one we are getting. We need to take that. There is a method, there is a formula. I'm going to show you that during our mathematical calculation part. Then what are the key concepts we understood till now? So the first point is that we have to take one weak learner. First we have to take one weak learner. And one more point, here we are not taking multiple algorithms. When we are talking about weak learner, we are taking decision tree here. And that decision tree, we are changing the samples at each stage, and we are making that that set of data to learn. to learn the pattern. So that's nothing but your weak learner. So weak learner is going to be changed at each stage by adding or removing weights. Then we have strong learner. Strong learner is the one where we're combining all the weight, sum of those weak learners, and we're getting the strong learner. Then adaptivity, because the core idea here is that model should adapt by understanding the mistakes it did in the previous stages, right? Suppose you have 50 weak learners. At the 50th weak learner, we are getting one strong learner. That means it has understood all the past mistakes of those 49 stages, and it has evolved, or it has adapted those errors, and it has changed its patterns. So that's nothing but your adaptability or adaptivity. Then we have bias variance trade-off. We understood that Adaboosting reduces, or it's going to reduce the bias. How? Because it's going to work with multiple samples. It's not going to take the single sample. If you take multiple samples, the data is going to or the data points which it is understanding, or which it is learning throughout the process, it's understanding the real patterns of those data. Then that's how it is reducing the error part, and the error part is less. That means the bias is less for that particular data set, and it is increasing as it is reducing the bias. It's increasing the complexity. That means it's increasing the memory capacity of the model. It is increasing the complexity of model, so that a machine will give more stress to understand the generalization part of the data set. So that's nothing but like it is handling the biased variance trade-off. Then we have few advantages of Adaboosting. So one is the improved accuracy. Just the way I said that as soon as you will work with bias and variance trade-off, definitely it's increasing the accuracy, right? It's going to increase the accuracy. The accuracy which we will get with a normal, normal algorithm, it's going to be different, because we are taking that same algorithm and we are improvising it by its, rigorous processes involved in this. Then it's easy to use, because we understood that as the concept wise it is easy, so definitely it's easy to use. And it's available in scikit-learn library, and I'm going to show you that during our coding part. And definitely it's going to reduce the bias, just the way I said how it is reducing, and because of the iterative process. And we have few disadvantages as well. So it's sensitive to noise or outliers. Why? Because it focuses on misclassified points. Mostly it's going to focus on misclassified points, and due to that the outliers or the noise are going to influence the model. It might influence the model, and that's how it's going to affect the performance of the model. So that's what your sensitivity to noise or outliers. And it's intense. The sequential nature, like the way it works sequentially, which prevents parallel processing, and it's making it slower to your system, to your processor to work on, just the way our XGBoost is working. Our XGBoost is working on parallel methods. And it definitely requires quality data. Like whenever you're working with Adaboosting, you need qualitative data, clean data. Like it should not be having any kind of outliers, any kind of errors, no much variance of the data set. So those kind of things also we need to take care when you are working with adaptive boosting. Then we have few real-time applications, and we know that all the algorithms are getting used in almost all fields nowadays. And it has been used from longer time. So just like the way one is a face detection, and it was used in face detection and spam filtering, in case of spam filtering, classifying mails as a spam or not spam. Then we have anomaly and fraud detection. In case of fraud detection also it is very helpful. Then we have medical diagnosis stages also it is used. Now let's quickly go to our whiteboard and understand the whole concept. I'm going to show you one very small example with a small data set, and we will see how it is calculating these steps in general. So let's explore that. So here this is a very small data set which I have taken, and if you see here that I have taken a small data set where we are checking that if my email is containing any free word, that means it's a spam, else it's not going to be a spam. That means you can see here that my data set E1, E2, E3 and E4, and you can see that my data set is already saying that if my data contains or my email contains free, yes, that means it's a spam. That means it's a label. Spam means +1 and not spam means -1. Then here, in the E2 part, we can see that in my E2 part, it is saying that it's a yes. That means it's a spam, right? Then in my E3, it is no. That means it's a not spam. However, in my E4, it has predicted wrong. You can see that data point has predicted wrong, right? If it's a yes, it is saying it's a not spam. But however, it is a spam, right? Now, let us understand what is the first step. My first step here is adding weights, right? So, I have 4 data points. That means it's going to be W1 equal to W2 equal to W3 equal to W4 equal to 0.25, because I am dividing 1 divided by 4. So it's 0.25. So we got our weight 4. Our focus is on 4th number, right? E4, email 4. So I got 0.25. Now we have to find out the weak learner. Weak learner 1. So what we are going to do for my weak learner? I have to find out the error part. What it is going to be my error part, guys? So here what I am seeing, like in my data set, actually it is saying like this, but it should be in this way, right? If I draw it, E1, E2, E3, E4, and here this one is +1, +1, -1, -1, and this is correct, this is correct, this is correct, but this is wrong. That means our model 4 has wrong prediction or wrong value. So for that, my error part or E1 is going to be 0.25. It's the same, like whatever the weight we are taking, that's going to be the error part, right? That's the one we understood, right? Whatever the adding sum of the weights is nothing but your error. And here we have only one weight, so that's going to be your error. Now we will calculate our alpha part. So it's going to be half of logarithmic ln, natural logarithmic, 1 minus 0.25 divided by 0.25. This is the formula, right? And approximately I'm getting a value of 0.5. So I got my weak learner 1's data alpha, right? Now what is the next step? We have to upgrade our weights, right? So how we are going to upgrade our weights here? What we understood? We understood that our final, like whatever the weights we are going to get, it's going to be updated now. And suppose and how it is getting updated, it is going to multiply each values with e to the power alpha. We understood that point, right? So now if we'll see the updated email and weights, then it's going to be E1, E2, E3 and E4, and here it's going to be 0.17. I just did that calculation, and 0.17 0.17 and 0.43. So these are the values we are getting, suppose. Now what we will do, we will find out by taking these values. We are going to calculate our weak learner 2, right? Weak learner 2. And what we are going to consider, we are going to change the rule. So in the previous rule, what we understood that if my email is containing just a free word, then it's going to consider as a spam. And on what we are going to focus our rule, we are going to focus our rule on that E4 or the email 4 only. So my new rule is saying, suppose my new rule is saying that if my email is containing spam and minimum word is less than 5. So in that case, I am getting, suppose my new error I am going to get is error 2, which is nothing but 0.7, because that's nothing but the weighted average or weighted sum of all my existing errors, right? Or for all the data points. Now we will again find out the alpha 2. Alpha 2 again half into ln 1 minus 0.17 divided by 0.17 and approximately I'm going to get 0.8. And what we understood that the more alpha value we are getting, the better the learning process is going to be. That's the fundamental here. Now we are getting the alpha value correct, like almost approximation. Now we can stop our learning. We understood that our data points are learning better now. Now we will finalize, or we will understand to the new point, or what would be the final prediction for my E4, because that's our problem, right? That is nothing but a problem. We are facing issues with E4. E4 is not able to predict properly. So we need to find out how we are going to calculate, or how we are going to understand to which class it belongs, whether it belongs to spam or not spam. Now let's see that. So how to understand that? We have a final prediction formula. Final prediction, which are calling as h of x, equal to sine of alpha 1 into h1 of x plus alpha 2 into h2 of x. We found our sine of, what is our alpha? Alpha 1. Alpha 1 is, I think it's 0.55. Alpha 1 is 0.55 into, what is my h1x? We got -1 plus alpha 2, 0.8 into final prediction plus 1. And we will take sine of it. So if we take sine of it, we are getting plus, the output we need to take. What is the output we are getting? So we are getting almost the value is 0.25 minus of 0.25. And why, now you should understand why we are using sine of. Sine of. You need to understand to which class it belongs. For that, we need to always use sine of. So when we are using sine of, that means we are inferring from here that this class belongs to -1, because my sign is minus. So that's what our inference, the final one, that it is a not spam class. Because if we'll go to this side where we have our data set, we can just observe that carefully. That means my email does not contain free word. It's just a consideration which you have taken while our study, right? So that is nothing but your complete intuition, and we understood that. And we will meet during our next videos, guys, and we are going to understand the coding part of it, how we are going to implement. And these concepts are very important because these are the frequently asked questions during interviews. So just stick to this channel to understand all this perspective of concepts. And we'll see you. And please start subscribing if you really like the content. Share this link to all your friends. Like, provide your comments, provide your feedback, so that it will boost me to work more effective way on day by day basis. So see you till next time. Bye.